Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing for our cloud providers at VMware. And today I'm joined by Joe and Martin. Welcome, guys. Thanks a lot for coming on board Feature Fridays. And today we're going to be talking about sustainability yet again. This is probably about the 10th session we've had about sustainability and different options and solutions that VMware has. But we're going to be addressing a little bit of a different angle today, talking about a solution called DeepCooling, and really the opportunity that cloud providers have to kind of get involved with a proof of concept of this at the moment. So let's start with a round of introductions. Joe, why don't you go first and introduce yourself?
Yeah, hi. So my name's Joe Bagley. I'm the VP and CTO for EMEA here at VMware, covering every product we do. And I've been here for 12 years now this month. Thanks, Joe.
And Martin.
Yeah, thanks, Guy. Yeah, I'm Martin Hoskin. I'm Chief Technologist for Cloud in EMEA. So I've been at VMware 9 years, and pretty much everything that comes under the cloud banner from a public cloud perspective and our partners' perspective falls under my remit.
Thanks, Martin. Okay, so let's start with the general kind of sustainability challenges and issues that we've seen. Okay, so VMware has been producing a bunch of solutions. We've had a green agenda for a long time. For our cloud providers, we have various carbon offset calculators. vSphere is obviously virtualization is a starting point for all kind of data center sustainability practices. And really what I wanted to gain from you guys particularly is what are you seeing? I mean, there is legislation changing in EMEA, in Europe particularly. I think January next year, people are going to have to start reporting on larger companies and providing transparency to auditors that have kind of yet to be verified. But there's a lot of, I think, concern from customers about where this legislation is going to go. What does it mean to them when they move to cloud? How much transparency can they get? Joe, in your experience, what's the kind of the real edge here? What's really pushing this forward with velocity?
Yes, a few things. I mean, there's two big ones. The first one, obviously, is energy pricing. I think the recent rise in energy pricing, particularly in Europe, has made people a little bit more inspectful of their energy usage than ever before. We've been banging on in the industry about energy usage in data centers since we started. But I think the recent energy cost rises have made a lot of people look a little bit more at what energy is being used where. So that's one reason. The other one is what you just mentioned, the CSRD, which is the Corporate Sustainability Reporting Directive that's coming in Europe, that actually some of it kicked in January this year and will kick in full flow in 2025. And I think you put those two together, and I'm now seeing an awful lot of organizations that have talked about sustainability and maybe done bits and pieces here and there with regards to their operations, and particularly in the context of this, their data center operations, now starting to realize that focusing a bit more seriously on the energy usage of their data center, how to optimize that, and then more importantly from the CSRD perspective, how to report and track and report on that is actually also becoming very important. So across the board, from let's get ready for legislation, let's get ready for the cost problems we're having and are going to have, that everyone's starting to look at this. But then at the same time, we're seeing a huge increase, particularly in public sector RFIs and RFPs, but more and more now from the private sector, where ESG more widely, but specifically the sustainability portion of that, is becoming a major percentage of that RFP response and request. And so, you put all that together, ESG is no longer some kind of buzzword or tick list. It's actually something people care about. We've got rising energy costs, and then legislation like CSRD and others coming in. I think, if you're not looking at sustainability and energy usage within your operations right now, then it's about time you did. You're probably a little bit late. So it's time to catch up.
Yeah, I mean, it's catching up, and cloud is always changing as well, which is a constant problem. As you mentioned, cost is increasing, so budgets are becoming a problem as well. And I think when you combine all of those factors together with merging legislation for the EU, but also each country, and as you actually rightly identify, I think in the UK, it's 10% weighted of the RFI bid to have sustainability as a proportion of that. It's becoming much more important for customers as well as service providers. So Martin, you talk to a lot of service providers. What have you seen them kind of start realizing? How are they going about kind of budgeting this as well?
Yeah, so I think our VMware cloud providers are ideally placed to really help their customers on this journey. When legislation comes along, when new laws come along, they have to face those challenges. Just like when we see the introduction of GDPR, and later this year we'll see the introduction of the EU Data Act in many countries across Europe. Our cloud providers are ideally placed to help their customers on that journey, and ESG is exactly the same. If the ESG mandate, is incredibly relevant now, it's incredibly relevant now. It's a growing mandate, and these customers are going, like you say, are going to be demanding our partners to be able to deliver solutions that meet not only their current requirements, but these are long-term contracts. So you have to meet those long-term requirements as well. So cloud providers are ideally placed in that situation to advise customers and work with customers and help them, both deliver from an ESG perspective, but also deal with the legislation, also deal with the legal frameworks around this, which is going to become, as you just said, increasingly challenging. And when they're responding to RFIs and RFPs, whether it's government or an enterprise customer, as you rightly say, these are a huge relevant part of an RFI now or RFP, and they're not going to win those bids, and they're not going to get those engagements unless they're able to meet these requirements.
Yeah, and creating a sustainable strategy is kind of an all-encompassing thing. I refer to the greenhouse gas protocol, looking at the different scopes that are there, and I think there's first of all some understanding of what this really means. Then it's looking at what are all the components I need to measure and monitor. And those two things, we've seen customers struggle with just, volume of data. When you start asking about supply chain and everything else and their suppliers, which has an impact to, how they produce their solutions, it gets awfully complicated. Joe, when we're talking about our VMware cloud providers, obviously they're very well placed. They own and operate their data centers, 99% of them. Yeah. So they've got really good understandings, and a lot of them are actually on our zero carbon committed program already. When you start looking at a customer either moving from a public hyperscale cloud back into a service provider or a co-location facility, or maybe even back to prem, what type of attributes of kind of greenhouse gas protocol are important for the customer to understand, but also for the service providers to realize they've got to provide transparency on?
Yeah, so if you get down to how people are doing, the broader reporting here, you're looking at scopes 1, 2, and 3. And if you understand what scopes 1, 2, and 3 are, most of it, when you're looking at public clouds, is scope 3, which is a supplier to that business. You're providing, and scope 3 is a big and a wobbly place to be when it comes to looking at carbon calculations. So the more transparent, the more open, the more easy it is for customers engaging with a cloud provider to see the carbon consumption of their exact requirements. And even, I think putting that alongside the pricing, the price list, etc., rather than just an after fact, literally, if you're going to do this, it's going to cost that, it's going to do this is how much a year, this is how much whatever. So I think the more we're seeing people get that up front, the better. So yeah, looking at that broader spectrum of the scope 3 emissions that people are going to have to account for in their reporting is really important, because obviously they're responsible themselves to scope 1 and most scope 2. Then you put that in the context of sort of the global sustainability goals from the UN GSG 9, which covers generally more generally infrastructure, which really is everything we're doing as well. It fits into a much bigger picture. But you're very right that the challenge is metrics. The challenge is what are we measuring and how and why. And different organizations are being measured in different ways. Different organizations are looking for different metrics. Some are being actually measured just on how much energy they use. Some are being used on the carbon impact. Some are being used on both. It's interesting across the board in different countries and around the region of EMEA, I should say, and more specifically Europe's a bit easier, but around others, some people looking at different things. And it's not just a European problem. It's important to understand. I'm having the same conversations around the whole patch of Europe, Middle East, and Africa. Even so, in the Middle East, where people think maybe energy consumption is not so much of an issue, it really is becoming very, very important too, even for those that are looking at having European operations as well. So yeah, looking at the big challenge when you sit down with any customer is metrics, and that's why they sort of like the green score stuff. And all of that comes out of what we're doing in the office of the CTO. And in the office of the CTO, we're looking at those sort of advanced projects of how we can help put technology into our technology, not just reporting, but bits and pieces into our technology that makes it easier for our customers. So we've had stuff like, dynamic resource scheduling and, dynamic power shifting, DPM, and all these different technologies to make it easy for a long, long time. Now, I think it's all sort of bringing these things together. And that's where the project like DeepCooling that, Martin's here to talk about is really, really important. And that's why we're here today, because it makes it a lot easier for our customers to start to meet some of these requirements. And it's exactly what we're doing at the Office of the CTO. But equally, we can't do this in isolation. And so again, we're here to sort of say, look, we need some people to come and help us work this out. We're looking for some people out there with real stuff and real problems in the real world where we can work on them together, because that's really how we build and make stuff now in the Office of the CTO.
Yeah, I think when VMware talks about cloud smart, we talk about a hybrid operating model, multi-cloud endpoint destinations. Now we've seen sovereignty become a major concern. Sovereignty is kind of the G, if you like, in the ESG, and a bit of the S maybe. Now we've got the E coming in here, and we're almost looking at kind of intelligent workload placement aligned to sustainable infrastructures that could run on, as well as being part of the decision criteria about where you run and operate your cloud infrastructure. Particularly if you look.
That's huge, and that really is huge. And we've had one of my favorite examples of that with a customer. If you're out there as a cloud provider looking at this is we had one customer that we were doing a migration to public cloud with them, and they had, from an IT perspective, justified it. It was exactly what they wanted to do. Everything was great, but then they realized they didn't have budget that year to achieve the migration they wanted to do. And we kind of put the thing on pause and hold. We're going to wait until the next budget year. And then someone found that there was a sustainability budget. And then actually by making the move to cloud, they were going to save, I think it was something region of 80+% of their carbon reduction target for that year by this IT project. So this for the whole org, not just for IT, but for the whole org, they could be 80% of their carbon reduction target by an IT project. Then the most senior management started allocating money to IT that they didn't know existed before, because it was helping meet the sustainability targets. So this isn't necessarily about, just energy reduction. This is about overall business impact. And, there's funds out there to make these differences that maybe IT departments haven't even tapped into before. So, it can form a core part of a strategy as well.
Yeah, absolutely. And as you say, an organization strategy, not just an IT department strategy, is really critical to realize. Okay, so Martin, we're here to talk about deep cooling. Deep cooling, as Joe said, right? We need help from other suppliers, capabilities, so we can measure these KPIs, so we can optimize our infrastructure for sustainability. What is deep cooling, and how does it fit into this conversation? Okay,
so as we know, VMware's got this long-term commitment to sustainability as part of our 2030 goals, etc. And a virtual part of that is really address these urgent business needs of being able to manage this data center, supply chain, this data center electricity, and making that sustainable as much as possible. So to address these needs, VMware has once again created a software solution to a hardware problem. DeepCooling is an AI and big data platform that is used to predict and match the optimal parameter combination of cooling in the data center by modeling with machine learning. So using operation metrics in real time of critical equipment and the cooling chain across the data center, monitoring this data in a dynamic environment and the energy usage, DeepCooling reduces energy and costs by dynamically adjusting parameters in each link of the cooling chain. So let me drill into a little bit more about what I mean by that. So, for example, DeepCooling models various physical systems, such as the power load, heating, the cooling of the entire data center environment by using both historical data and data in real time. And it uses that to control the cooling system based on the based on the results of the load that is running at that particular time, in different aspects of the data center. So as a result of that, energy efficiency optimization of deep cooling is a dynamic process, an iterative process. So this really, this is a joint project really between VMware, DeepCooling, Intel. So in China, for example, VMware and Intel are converging ecosystems to provide innovation in edge computing, artificial intelligence, and carbon neutral computing. For example, with Intel, with Quark Data and VMware, we're cooperating to develop a joint solution to accelerate the adoption of sustainable carbon neutrality computing technology in data centers worldwide. And deep cooling helps us achieve this. So it allows companies to optimize the energy consumption and performance of the entire cooling system in the data center through continuous edge intelligence intervention in real time. So under this joint venture, there are 3 parties who are building this solution, and it's been implemented in several sizable domestic data centers already, helping customers to significantly improve power usage effectiveness and reduce carbon emissions. So how does this work? Well, so data is collected from all parts of the environment, the machine room, air conditioners, the physical space, manual data can be entered, et cetera, et cetera. So, but using intelligent sensors and a gateway device to summarize the data and generate immediate data, such as machine room air conditioning redundancy and machine room heat maps. So after connecting this system to the data center infrastructure, deep cooling collects data on temperature, humidity, energy consumption, air conditioning load, and all the associated water lines and the within each machine room. This data then provides a set of data display systems. So it virtualizes and relays this visually to the data center provider. This results in a clear picture of energy usage that intuitively and graphically shows temperature differences and heat maps of the cooling and heating equipment in the machine rooms. So in addition, this solution virtually shows the thermal distribution and energy consumption of each cabinet and air duct, through which users can rapidly discover and deal with any abnormal device or settings. So hot zones, effectively. Based on the data collected by the overall system, the cooling system in the data center is modeled in 2 steps. So the first step to the model is the use end of the actual cooling capacity that is in the server room. And the second step, just get the slide here, the second step is to model the data center load volume to better control the centralized cooling source. So by modeling this overall physical system of the data center, the system realizes improvements to the traditional feedback-based cooling controls of the cooling system. And the result is better energy consumption, performance, enhancement, and temperature control. So the airflow is effectively optimized and controlled, and of each cooling system and at each moment is being trained by the machine learning model, and then accurately can match that system's output according to the load and reduce its energy consumption. So the platform digitizes the on-site equipment to build a digital twin and optimizes the control of the equipment in the server room for a whole life cycle of that data center. So the main types of equipment that's controlled by the system are, of course, the air conditioning units, the water chilling units, the valves, the pumps, the water lines, fans and cooling devices, and all the related equipment as well. So this system achieves this optimal control of the overall cooling system of the data center through a distributed computer system based on edge inference. Each server room has an independent control node to execute the model inference at the edge, calculate optimized control, and then control the air conditioners. Similarly, in the cooling source, there's also a matching edge control node to execute relevant optimization control. So this system typically sees between an 18 and 25% reduction in cooling costs, and up to 30%, as we can see here with this example on the slide. And this in turn leads to a power usage effective improvement of between 0.1 and 0.15. In addition, the system requires minimal changes to the data center hardware and does not negatively impact the normal production during the implementation process. Therefore, the return on investment of deep cooling is more than double of that hardware-based energy consumptions within 18 months. So, just to summarize here, so deep cooling solution, the data virtualization and dashboard components of which we announced at Explore in 2022. And the visualization elements of this that I've shown you in these slides, these all come through ARIA operations. So it's deeply integrated into our VMware vision around ESG. So work is continuing. This is an ongoing project, with the deployment of this deep cooling solution, and we have lots of partnerships already. More than 30,000, I think it was, 30,000 cabinets already being optimized for cooling perspective, from a cooling perspective, with this solution. Return on investment is typically 18 to 24 months. So if you are interested, and you see this sort of call to action, which we'll repeat again in a moment, there's some links here embedded in the slides, which I'm sure we'll share, and also this email address, flowgate@VMware. If you reach out to these guys who are working on this project, they'll be able to come back to you with some additional information and hopefully be able to move forward with you. Did that make sense?
Yeah, absolutely.
Kind of.
Absolutely. I'm really pleased to see it's all in ARIA operations. And I'm just thinking in my head, there's an investment from a provider in here, and obviously somebody edge compute perhaps, and the actual solution itself. As you said, hopefully minor hardware changes, which is a good thing. But I'm just trying to think if there's opportunity. There's obviously opportunity in terms of the savings, but could there be opportunity in terms of monetizing this as well? Particularly for those doing HCI private cloud type scenarios, to be able to present that and report back to the customer, and give them like full transparency on how much energy is being consumed, not just from the virtualized estate, but also a slice of the kind of the data center attributes as well. So there's probably services to be made out of this, as well as, obviously the results you get from using it.
Yeah, absolutely. I think, for MSP type partners who manage customers' infrastructure, manage customers' data centers, and have control over this cooling equipment, I think there is an opportunity there, as a managed service, effectively, energy consumption or cooling as a service type of platform to be able to deliver that. But at a very high level, what we're doing here is optimizing airflow. And this isn't new. We've been doing this, for many, many years in data centers. I have a number of my previous roles. I spent a lot of time in data centers, and you get to know where the cold air is coming from and where the warm air is going to. So, so you position yourself optimally so you get the best of both worlds when you're standing in there. But the aim here is taking this to the next level, using machine learning to optimize that airflow through the data centers. So, you're reducing the overall cost of consumption of energy there, and prolonging the life cycle of the hardware, of course. Hardware. I've been fortunate or unfortunate enough to be in a data center where a cooling system has failed, and you're having to evacuate and literally open side doors to get air because things are switching off. So I've had that experience many years ago. So there's absolutely no question about how optimizing this and minimizing the cost will also increase the longevity of the hardware as well.
Well, you mentioned a really good point there. I mean, I think, was it Google who had data center outages in London last summer due to the extreme heat? I think it was one of the hyperscalers, and when you consider that, then you're going to have to run your HVACs at like absolute full power just to maintain like an equilibrium. Actually, if you can optimize that better, then that's almost going to be kind of on parity with delivering better SLAs as well as better sustainability.
Well, also about optimizing workload placement as well, right? So this isn't just optimizing the airflow. This is about moving things around so they're running in the right place too, which is really important. So I've worked in helping cooling data centers for over 20 years now, and we've come a long way in 20 years since we first put virtualization in as a recommendation in the code of conduct for data centers in Europe. But that ability to move workloads around, optimize workload placement, as well as optimizing what's going in the data center, and that being done together in unison is really important. And I think it starts to get a little bit more intelligent, so people can start to get access to those sort of higher order intelligence in terms of the workload placement that they wouldn't really get normally.
Yeah, you're absolutely right. This is This is stuff that needs to be automated. It can't be done manually because it will be a full-time operation. Yeah.
Too big, and this is it. There's too many workloads running in too many places. One person can't manage this kind of stuff. And also data centers aren't homogenous either. There's different cabs for different people and other stuff. So you need to start managing things very, very carefully. So that's really what we're about here in the CTO, is about asking you out there to come and test this, to come and challenge it. This isn't really a done deal as far as we're concerned. This is literally us saying, okay, what have we missed? What should we be doing differently? What's completely stupid? How have we got the completely wrong? Is this, should we not be doing this at all? That's why we need some people out there with more real world scenarios and more real data centers and real workloads for us to play with, so that we can get this a lot more refined. We're certainly not saying this is a fait accompli, come and install it and we're done.
Yeah, absolutely. Okay, so sounds like a great solution. What the real ask here is for us to, or for our cloud providers to engage with those links, Martin, to to provide some of their time, I guess, to look at doing a proof of concept to this, to feed back to Joe's point, what is perhaps different in the region they're monitoring and running in that they require, additional capabilities to be developed or delivered. And really just to start engaging so we can start building a better solution for this overall.
Yeah, I think it's important that every data center is different. The architecture is different, the airflow is different, the equipment is different, and there is no one size fits all when it comes to data center optimization for airflow or cooling. So it is going to be a technology solution that we need here to be able to optimize that. There isn't, we can look at physical equipment and reducing costs to newer conditioning units, newer water cooling and gel cooling. Microsoft are doing some phenomenal stuff with submerged GPUs at the moment, and they're not in production yet, but they will be soon. But it's not one solution we're looking for here. It's multiple solutions that will take us into the sort of next generation, if you like, of data center architecture and optimization, because data centers are getting bigger and bigger. That's absolutely true. These big hyperscale data centers are getting bigger and bigger, multiple availability zones, and in a single region. We have to find a way of managing that, because as a species, we're now dependent almost entirely on this technology.
And to your point, that they're not homogenous. Yes, we've got technologies like isotope and others that have been, immersion cooling, other bits and pieces, but also the types of processors going in are different. As you highlighted there, GPUs, DPUs, the general XPU market in that space. We've got different types of processors going, and we've got ARM going into data centers. We've got all these different things. It's not just, okay, well, how do we put, fill in with x86 and optimize it? It's entirely not what it is. So the more we can start to get more data, the more we can make this more relevant, the better.
Yeah, absolutely. Okay, great. Well, listen, folks, the links are down bottom in the comments, and I'm also on the screen. Just want to say thank you very much, Joe, Martin, for coming on today, explaining a bit about deep cooling and having a general chat about sustainability. I always enjoy it.
Okay, thanks, Guy.
Thanks, Guy.
Cheers.